Good morning. I am Kushal Veer Singh, Mechanical Engineering Department, RCRT Jaipur. Today we will discuss the C chart, that is a type of a control charts. First of all, we will discuss the basic principle of control chart. The control chart is a graphical display of a quality characteristics that has been measured or computed from a sample versus the sample number of or time. The chart contains a central line, a upper line or upper control limit and a lower control limit as shown in a figure. At a horizontal axis, time is taken, and in vertical axis, the variables are taken, and there are upper control limit and lower control limit, and in midpoint or mid of lower and upper is the average or mean line. Types of control charts. Control charts are there are two types, that is variable and attributes. And variable control charts, the X bar charts, R charts, and X bar S charts, and C bars individual charts, and attributes charts, and P chart, MP chart, U chart, and C chart. Now, then our today topic is the control charts for attributes, that is C charts. Sorry. Healthcare and control charts. Control charts aid in process understanding, assesses process stability, identify changes indicating improvement or deterioration in quality used in hospital process improvement projects, accrediting bodies and governmental agencies, public health surveillance. Control charts for non-conformities, that is defect. The non-conforming item is a unit of product that does not satisfy the satisfaction specifications of that product. Distinction between a defect and defective is clear. That is, a defect is any instance of the item's lack of conformity to specification, and a defective item that fails to fulfill one or more of the given specifications. Now, what is a C chart? Originally proposed by Walter A. Seward, it is a control chart for non-conformities developed for total number of non-conformities in a unit, underlying distribution, Poisson distribution. Two cases are as standard given and standard not given. C chart when the standard given. First of all, we have to determine UCL. The formula for the UCL is equals to C plus 3 root C. C is the central line. LCL, lower control limit, is equals to C minus 3 root C. Note where C is the parameter of Poisson distribution. If lower control limit comes negative, take it as 0. And control C chart when the standard not given, let Ci be the C value for the sample taken from the ith subgroup, that is I is equals to 1. And then the appropriate estimate of C will be summation of Ci divided by n. And upper control limit is equals to C comma plus 3 root C comma, and central line is equals to C comma C a dash, and lower control limit is C dash minus 3 root C or C comma. C comma is estimated value of the Poisson's parameter. C comma may be estimated as the observed average number of non-conformities in a preliminary sample of inspection units. When no standard is given, the control limit is equation an equation should be regarded as trial control limits. One problem related to the C chart is taken to explain how C chart is used or applied. As a given table, data on number of non-conformities in sample of 100 printed circuit boards, that are sample number 1 to 13, and number of non-conformities is given as, and sample number is given for 14 to 26. For that, number of non-conformities is given 26 samples, that is 516 total non-conformities, and C dash is equals to 516 divided by 26 is equals to 19.85. Upper control limit is equals to C dash plus 3 root C dash is equals to 19.85 plus 3 root 19.85 is equals to 33.22, and central line will be 19.85. Lower control limit will be, as previously we will discuss, the formula for lower control limit is C dash minus 3 root C dash, that is 19.85 minus 3 root 19.85. The value will be 6.48. After removing the two out of control points, the estimate of C is now computed as C dash is equals to 472 divided by 24 is equals to 19.67. As the problem is described by a control chart is explained by the figure, revised control limits will be, upper control limit will be C dash plus 3 root C dash is equals to 19.67 plus 3 root 19.67 is equals to 32.96, and central line C dash will be 19.67, and lower control limit will be 19.67 minus 3 root 19.67, the value will be 6.36. An additional data for control charts for non-conformities. Other example is taken as sample number from 27 to 36 and number of non-conformities given, and sample number from 37 to 46. The number of non-conformities given, and after solution, lower control limit and upper control limit and mean is defined by a graph that is called C chart. So, as explained by previous examples or previous problem of control charts, we can easily solve this problem, and I suggest to students to solve the problem by using the funda of previous problems to for practicing the control charts problem that comes in university exam of our students. Final charts that will be find out by after solution of that problem is given, and the values of UCL and LCL is also. So I suggest to all the students of 6th semester BTech mechanical engineering The numerical problems of control charts like these problems in are comes in university exam. So we advise to practice these types of problems of control charts and quality management. Thank you.